Ever wonder how computer vision models go from this to this? Or how scientists know whether a segmentation model is actually doing a good job and not just guessing? I have a secret for you. Come closer. It's called IoU. Now you're probably wondering, what is IoU? IoU stands for intersection over union, and it's a metric used to evaluate image segmentation and object detection models. In simple terms, IoU measures how much a model's prediction overlaps with the correct answer, also known as the ground truth. To understand IoUs, we must define 3 key terms. Firstly, the true positive. This is the area where the model's prediction correctly overlaps with the ground truth. Next, we have a false positive. These are pixels that the model predicted as part of the object, but they shouldn't have because they fall outside of the ground truth. Lastly, we have false negatives. So these are pixels that actually belong to the ground truth, but the model failed to predict them. IoU is calculated by taking the intersection area, the true positives, and dividing it by the union, which includes the true positives, the false positives, as well as the false negatives. So now we're going to do a visual example. So the purple box represents the ground truth, and now the blue represents the model prediction. So the overlapping area that you see in the middle here is our true positive. This is what the model has gotten correct. Outside where it is not even in the purple, as you can see with the blue, that is our false positive. Now the part of the object that the model missed, also known as the purple, that doesn't include any blue, is our false negative. So when we calculate IoU, we take the overlapping area and divide it by the total area covered by both shapes. So our formula would look like this: the area of overlap over top, which is the 2 boxes overlapping, over the area of union, which is the total of both boxes. IoU values range from 0 to 1. An IoU of 0 means there's no overlap at all, and an IoU of 1 means that the prediction perfectly matches the ground truth. In real-world applications, a higher IoU score indicates more accurate models. So let's take another look at this visually. So again, the purple is the ground truth and the blue is the model. So all the way on the left, as you can see, there is the least amount of overlap. So that would be poor. And then in the middle, we get a little bit better. So we have a score of good. All the way on the right, that is what we should strive for. That is excellent. That would be closer to 1 on our IoU score. This is especially important in fields such as medical imaging, autonomous vehicles, as well as infrastructure inspection. IoU may seem like a simple ratio, but it plays a huge role in determining whether computer vision systems can be trusted in the real world. And that's how we measure whether a computer vision system is seeing what we actually want to see.